In this video, we'll go through the link-based implementation of your list ADT. Recall that a list starts with this label called head, and moving forward, each LL node will be linking to each other in this fashion. The very last node ends with a null terminator. Recall from our collection implementation, we have two pointers. The very first one is called front, which points to the very first element of your list. The second pointer is called rear, which points to the very end of the list. We're using these two pointers to keep track of where we are inside this implementation. This example, as illustrated, shows that the entire list is full because the rear pointer is pointing at the end, right before the null pointer. Let's say your list only has two elements, and the first two elements are occupied, and your rear pointer would have been pointing to the second element instead of all the way at the end. Let's look at some code. This is the set method that takes in the index and the new element to be set at this particular index. First, we check to see if the index is out of bound. If it is, it throws the index out of bound exception. Secondly, let's move on with our linked list operation. Initially, let's create a reference called node, which is equal to the front. So we have this node pointing to the front, which points to the very first element of the list. Let's say for the purpose of illustration, the node that we were trying to remove at index -1, which is the index element, because array indexing starts with 0. So this is index 0, and this is index -1. So the index location is at this node, which is to be removed. Now, starting with node equal to the front, initially, our reference node starts with front. And through this iteration, we're able to move the node equals node get linked to the next one, until we get to this target location. At index -1, your node is pointing to this removed element. Then we get the information out of the node that we're removing into hold, and this hold is to be returned. Remember, set returns the information for the node to be removed. Once we have the information of the removed node, we then set the new information to that of the new element. This completes the set operation. And given this loop, we're dealing with O of n. Let's study iterations next. This is a pictorial representation of your entire iteration mechanism. Recall, in addition to the front and rear pointers, with the iteration, we are also creating 3 more. And they are previous position, current position, and the next position, respectively. When your iterator object is created for the very first time, your next position is pointing to the very beginning of your list, which is the front. And both your current position and previous position are set to null. This is the initial condition. When this iteration calls on next, in this statements right here, your next position then points to the very second node, and your current position points to the very first, whereas your previous position remains null. It is kind of hard to visualize this, but once we look at the code, it will be a lot more apparent. In general, iteration keeps track of previous position, current position, and next position. So there are 3 additional pointers at play, which makes the iteration mechanism slightly more complicated than the array-based implementation. Let's look at the remove mechanism next. This is the remove operation for a situation where your current position is in the middle of a list, not in the front or at the rear. The element sitting at the current position is the one to be removed. Let's say current position is pointing to cat. In order to remove this cat element completely, we first nullify your current position and set your previous position pointing to the element before cat to the very next one. When the element pointed to by current position is removed, it is garbage collected by Java. The link between ent and ear must be established. Therefore, we look at previous position, which points to N. We establish that connection by virtue of linking the previous position to the next position through this bridge. And the remove element is completely removed. There won't be any link between cat and year at that point. This entire mechanism looks easy, but it's quite complicated. I encourage that all of you to look into code, drawing some pictures like those shown here, and validate these steps in code to aid your understanding. There's no magic in getting better at this. You must understand the mechanism from a visual standpoint and then try to translate these steps in code. You might have to review code a few times to really appreciate what's going on here. This is not the only way to implement your linked list based list, but the ideas are pretty much the same across various different alternatives anyway. We'll review a small portion of the code to illustrate one or two use cases in the next video.